In this example of taking a standard version of a quadratic form to vertex form, we will note that we have a -1 coefficient. Now, I'm going to show you an alternate way of how some people convert this. So we're going to have negative, or y equals negative x squared minus 6x minus 1. Now, some people will, let me take this and kind of go back and go here. There we go. They'll take this -1 and they'll push this constant way out there. Okay. Now they'll factor out a -1 from the quadratic term to get it to be a positive. Okay. Which means that's a 6x. Now, close parentheses. You still have -1 right here. And what we're going to do is this. We're going to take half of the 6, so that'd be +3, and that's squared. Okay. Now, that being a +3 squared, and I just messed that up by doing that. Let me fix it. All right. There. We will add 9. Now, seeing as we didn't go across the equal sign, we need to make sure that we keep everything kind of balanced. So if we're still on one side of an equation, so if we're adding 9 here, we need to make sure that we're turning around and minusing 9. Okay, but remember that this minus is actually being multiplied by a negative, or this 9 is actually being multiplied by a -1. So this is what you get right here on this side. Now let's do a little bit of cleaning up. Y equals -1 x plus 3 squared. Now this right here will give us -1. Negative times a negative is a positive, so that's +9. So -1 plus 9 is +8. All right, so let's find the vertex off of this while we're finishing up. The vertex would be -3, 8. That's why the vertex form exists, is it's easier to pull out the vertex from it. Okay, this concludes part 2's video of taking it from a standard form to a vertex form.